physics, force is defined as push or pull of anything. The force has both magnitude and direction, and hence it is called as a vector. Some of the real-time applications of force include pressing the buttons of a calculator, hitting a golf ball with some force in an open field such that the ball changes its direction, and horse race. Torque is defined as a force into perpendicular distance. The length of the tap is the distance, and I'll be applying a perpendicular force such that torque comes into action and the object moves. In the similar way, while removing a screw using a cutting plier, the length of the cutting plier is the distance and the upward or downward motion is considered as a perpendicular force where torque comes into action. Any body in motion gains speed or velocity depending on the situation. So, situation is the only thing which tells us whether the body has speed or velocity. So, what is the difference between speed and velocity? This is a major question in all of our heads since our childhood. Most of us have used velocity instead of speed and speed instead of velocity. So, the major difference between both of them is explained with the help of vectors. Velocity has direction, whereas speed has only magnitude. Mathematically, velocity is a vector, whereas speed is a scalar. Now, let us look at an example of a car moving at a speed of 30 km per hour. The word 30 km per hour shows that it has magnitude but no direction. Hence, speed is a scalar. Whereas, the velocity of the car is determined to be 30 km per hour due north. Here it has both magnitude and direction. Hence, velocity is a vector.
If you ever done any boating on a fast moving river, you know how difficult it can be to get where you want to go.
Application of vectors in water current and boat. Using vectors, we can say in which direction the boat moves, with which velocity the boat moves, how much time it takes to cross the river, determine how far the downstream directly across the river boat will hit the shore. Using vectors, we can also figure out the velocity of water, and we can also find out the velocity of boat in the still water. Now we are going to see all these applications in a small way.
We can also find the shortest distance using the vectors, where we can consider boat and water are the two components. When we consider again the velocity of the water is v, the velocity of the boat is u, when they both are moving in the opposite direction, then it is known as upstream. During the process of upstream, the net velocity decreases. When we consider the velocity of the water is v, the velocity of the boat is u, when they both are moving in the same direction, then it is known as downstream. During the process of downstream, the net velocity increases. We can also find the shortest distance using the vectors, where we can consider boat and water are the two components.
So let's say you have a plane that's moving west at a constant velocity. But you also have a wind current that's flowing north very slowly. Together the plane movement west and the wind's movement north makes the plane move diagonally or northwest. Well, we just have to look at the movement of the plane as a vector problem. The vector drawn here is pointing in the direction of the plane's movement without the influence of any outside forces. This new vector shows the direction of the wind's movement north. A resultant vector is drawn from the tail of one arrow to the head of another, ultimately pointing in the northwest direction, which is the direction that the plane ultimately moves. Let's say that velocity of the plane is 500 miles per hour west and the velocity of the wind is 70 miles per hour north. This means that you have a x component of 500 and a y component of 70. Each of these squared and added together, and then the square root of that answer should be taken. This will give the magnitude of the resultant vector's velocity. In this case, the resultant vector is moving at 504.876 miles per hour. To find the direction of the resultant vector, we need to find the arctangent of the y component over the x component. So, here you take the arctangent of 70 over 500, which gives you 7.97 degrees north of west. Thank you.
Rain is liquid water in the form of droplets that have condensed from atmospheric water vapor and then become heavy enough to fall under gravity. Rain is a major component of the water cycle and is responsible for depositing most of the fresh water on the earth. It provides suitable conditions for many types of ecosystems as well as water for hydroelectric power plants and crop irrigation. Raindrop is also an application of vector. One of the most basic applications is probably how we judge the direction of falling raindroplets when we are moving in rainy terrain. Based on how fast we move, we can ascertain the direction of the falling droplets by the triangle law of vector addition.
Vectors play a major role in cricket. It depends on the batsman in which angle he shots and with how much velocity he hits the ball. Here are few different angles of the vector between ball and bat. If everything fulfills the requirements for maximum force, the ball goes to over boundary. Otherwise, there is a possibility of catch out or drop before fielder.
Vectors in software field. As we know, there are several programming languages like Python, Java, C++, R, etc. In each programming language, vector plays an important role. Coming to machine learning, vectors are used to represent numeric or symbolic characters called features. Artificial intelligence. Vectors are also used to store the internal representations of AI models such as deep learning networks and linear classifiers. Java. Vector implements lists interface like array list. C++. Vectors in C++ are sequence containers representing arrays that can change in size. R. Vector in R programming is the most common data structure. It is like an array of the data elements, each of the same type like integer, double, characters.
Basketball is also one example of vector application. First player can create openings for their team and can effectively drive towards the basket. Acceleration or the rate at which velocity changes over time helps player quickly to reach their top speed. Vectors are used to show velocity using magnitude and direction. In sports like basketball, is vector used unconsciously by the players. Ultimately, they shot the target or throw the ball at the direction which an angle which is done by the knowledge of vector. Vector is game in game. Vector is used to store position, direction and velocity.
Application of vector in military usage.
In this video, we will know about the cannon which is used in army. A cannon is any piece of artillery that uses gunpowder or other usually explosive-based propellants to launch a projectile. It varies in caliber, mobility, rate of fire, angle of fire and range. Different forms of cannon combine and balance these attributes in varying degrees depending on their intended use on the battlefield. So for this we need vectors. By the World War I, all of the major powers were experimenting with aircraft mounted cannons. However, their low rate of fire and great size and weight precluded any of them from being anything other than experimental. Now even we will see the same application even in the gun also.
We are going to see use of vectors in games. Samus and Riley are two characters here. We can figure out distance between them. This can be applied to any character for projectile, Pokemon range attack, etc. To get the difference, we take destination minus start. We don't know magnitude. To find magnitude, we use Pythagorean theorem. That is, C is equals to root a square plus b square. For 2D vector, magnitude is root x square plus y square. For 3D vector, magnitude is root x square plus y square plus z square. For n-size vector, magnitude is root x square plus y square plus so on plus n square. Here is a situation. Samus and Rayleigh are facing each other. For example, we count 10 on x-axis. To make it convenient, since there are 3 platforms, we count 3 on y-axis. Samus' position is 0, 3 and Rayleigh's position is 9, 3. Let the range of Samus charge shot be 10. To get vector difference, subtract 2 positions. The vector difference is minus 9, 0. Magnitude is root 9 square plus 0 square. The distance we get is 9. If the distance between Samus and Rayleigh is less than 10, it's a hit.